All right, welcome to video 5F2. This is using the law of sines to find a missing angle this time. The last two videos, we did law of sines to find a missing side. And as you know, whenever we're finding a missing angle, there's always just one additional step. So wanted to show you a couple of examples for this type of problem. The first one comes from example 1b, which is in your textbook, and we start with triangle XYZ. So we have XYZ, and XY is 14. The measure of angle Y, we're told, is 92 degrees. And the side XZ is 17. And then what we are asked to find is the measure of angle Z this time. So since we know angle Y and angle Z are the angles involved, I'm going to modify my law of sines equation a little bit, you guys, so that I'm using those letters. So let's start first by modifying that sine of y over little y. And as we know, little y has got to be that 17 because it's opposite angle y. So sine of y over little y has got to be equal to sine of z over little z. And little z is going to be 14 because that's the side that is opposite angle z. So this time we can plug in what we know. And we can plug in 92 for y, so this is sine of 92 degrees, over my y, which is 17, equals the sine of z, and that is my unknown angle, so we'll leave it as a variable, over little z, which is the side 14. Now, just like in the last video, in order to solve this, which is a proportion, we're going to go ahead and cross multiply. So we get 14 times sine of 92 degrees equals 17 times sine of z. And so what we need to do is we need to get z alone. And so first we're going to get sine of z alone. And to undo this right-hand side and get sine of z alone, we're going to divide both sides of this equation by 17. And that will accomplish us getting sine of z alone, which will be equal to then 14 times sine of 92 all over 17. Notice I haven't touched my calculator yet, okay? What we need to make sure that we're looking at is solving for sine first and then solving for z as a result. And again, in order to undo the sine function, we need to use the inverse sine function, don't forget. So we're going to use z then is going to be the sine inverse of that whole entire quantity that we just wrote down that sine of z was equal to. So that's 14 times sine of 92 degrees over 17, and we're taking the sine inverse of that. So on your calculators, what I would suggest to you is to find a quantity for this parenthesis and then do the sine inverse of that. And again, it's multiple steps because you are finding an angle instead of a side, but it's still completely doable, and you can watch that screenshot video that I gave you for this process. What we're looking at here is now finding an approximation with our calculators for that angle, and the instructions on your whisk are to round to the nearest degree. So when we do that, we get 55 degrees. Always at the end of a trig problem, we have to ask ourselves the question, does this make sense? And what we did in the last video, we're going to do similar to that here as well. Does this make sense? Does this make sense in relation to the sides that are given in the diagram with the results that we just got? So we are looking at the side information that we have is that little z is less than y. And so if that's the case, the measure of angle z, capital Z, remember, should also have that same relationship, because remember, the larger angle is always opposite the larger side. So the larger angle should be opposite the larger side. So measure of angle z is less than, or should be less than, the measure of angle capital Y. And if we go ahead and look at our diagram, The measure of angle capital Y is 92. And so I just need to check out, does the answer that I got, which is Z is 55, satisfy this inequality? Is 55 less than 92? And the answer there is yes, it is. So that tells us that the answer that we got from our calculator is a valid one with the relationships between larger sides and larger angles. And that's the process for finding a missing angle within a law of sines problem.